In the second video, we're going to get back to the questions that you answered on the worksheet for reading erosion and deposition. So be sure that you have that worksheet available on your screen someplace. You can split the screen with this video on one side and your worksheet on the other and make changes. I recommend that you use colors to make changes so that you can keep record of what you knew beforehand and what you're learning today. So here's the first question. How could weathering and erosion happen at the same time? And I've listed 3 different sentences that show both examples of weathering and erosion that occur in these same places. Now, your answers may be different than mine, but just check to see if you have these patterns. On this slide, you can see that I've used some coloring. So what's in purple, or hot pink, is a description of the weathering process, and the green is the description of what the erosion process. So if you notice on all of them that the weathering parts are all about the rock material, the source material being broken off or dissolved or being scraped off, and that the green phrases are all about motion, rolls down the hill, drops to the ground, or continues along with the wind, are all motion. So how is erosion by water actually gravity? Well, if the rain falls on the ground and gravity is pulling everything towards its center, the water has to go someplace. And so what it does is it moves along the ground or flows always downhill. So 3 ways that sediments are moved by water in a stream. We also use similar terms when we're talking about erosion by air, so in suspension is when small grains are moved with the water in the water. Saltation is a term we talk about how the larger pebbles and rocks flow on the bottom or bounce along on the bottom of the stream. And then the last is solution or dissolved. It talked about a dissolved form in the article itself, but that when the particles that are dissolved in the water, they just move along with the water. Here's an image that describes those different terms. On the left side, you can see what happens in a stream. You have the bed load. We're going to use the term load when we're ever talking about when sediments are within a water or air. It's the kind of what it's carrying. So we've got the bed load, which is the bigger particles that are bouncing along the bottom of the stream. This term traction is the ones that aren't going to bounce. They're too big, so they just slide along here. And then we've got the dissolved and suspended load. So these are particles that are either have been dissolved, like sugar dissolves in water, or salt dissolves in water, I guess is a better example, or particles that are so tiny the speed of the water carries them along. And those particles would be things like particles of clay or silt, sometimes sand, depending on how fast they're moving. The image on the right is showing what happens in the air and the terms they use. So we've got particles suspended or in suspension with the wind. Saltation is again used for particles or pebbles that are small enough to get launched by the wind and then land back on the ground. And then you've got creep, which is bigger rocks that, if the wind's hard enough or consistent enough, would just creep along the ground. So this next slide is supposed to be a video, but I'm not sure how to put this video, which is YouTube, in this this video. So there's a link below the image. Also, I will post this in Canvas. It's about 2 minutes long, but it really gives you a good idea of what's going on under the water. 2 things influence sediments moving downstream. One of them is the speed of the water that the sediment is being carried in, and the other is the size of the particle being carried. So the faster the water is, the bigger the sediment it can carry, and the farther it can carry that sediment. So bigger particles don't travel as far, whereas The tiniest particles can be carried really, really far downstream. And some streams just carry more sediment than others. And there's a couple reasons. One is those waters or streams are faster, so they can carry more particles farther downstream. And another reason is that the stream or river actually has a greater source of those sediments, those particles. So um, even though it might be a slower moving body of water, there's just tons of sediment or a huge sediment load. In these slides, you can see just variations of sediment load. So the top one is soil erosion from a farm, as is the one to the top right corner. If you go down to the bottom left, you can see the muddy Mississippi. The muddy Mississippi, especially lower Mississippi, huge sediment load in this area. And then on the far right, bottom right, this is the Toutle River, and the sediments in the Toutle River are slightly different color because they come from a glacier, and glacier-fed waters tend to be more of a milky color, which is interesting if you're ever hiking around an area that has a glacial river. It doesn't look clear or brown, it'll look a little bit milky. So this last section is all about distinguishing between the landforms we see in the environment and whether or not they were caused by erosion or if they were caused by deposition. These are the features that you can see in the image to the right that were caused by erosion or sediments being moved away. Things like waterfalls and rapids, tributaries, bluffs, meanders, V-shaped valleys, and rivers are all formed through erosive processes. On this slide, you can read the descriptions of these land features, these landforms that are caused by erosion. Floodplains, beaches, deltas, and oxbow lakes, all in this image, are caused by deposition or the depositing of sediments. And here are their descriptions. So this question was getting at, why do you think deposition or the depositing of sediments are happening in these places? Typically down towards the bottom of the mountains. And so one of the things you should have noticed is that the mountains, these areas aren't as steep. So if it's not as steep, the water's not going to be flowing as fast. And then if you get down towards the mouth of the river or down towards the bottom, sometimes these tributaries and streams are running into larger bodies of water, which slows that water down. And then also along the edges of rivers and streams, we can have areas where the water itself will slow down and drop sediments. So we have some nice little river beaches. Well, I exceeded my time limit of 5 to 8 minutes by a few, but I hope that you have a better idea about erosion and deposition. As always, if you have any questions or concerns, please email me or use the inbox in Canvas. Take care. Ciao.